In the last video we set up React. In this video we're going to look at setting up Redux and how a basic Redux flow works, discussing middleware, reducers, and stores. So in this case we are going to sidestep the boilerplate and setting things up with Babel and Webpack that we did in the last video, and we are going to instead install Facebook's scaffolding tool called Create React App. This is going to produce a much more featureful boilerplate application, which is going to include much more complicated production and development Webpack configuration scripts, as I discussed in the first video when building our bare bones one. So now what we can do is, after installing that globally, assuming you have Node and npm installed, go say, we'll call it React thing. Let's take a moment, especially on the first try. Create React App is customizable, and then when you're finished using their basic scripts, you're able to eject and make your own changes and lose their dependencies. So one substantial feature that is unavailable in our basic Webpack build, even with the Webpack watch feature, is that Create React App includes a development build server that will allow us to stream changes in both code and style sheets to the browser live. Oops. So we're going to start that dev server now. And we'll see the stock page that's included. There's basic components. We'll see CSS animation rotating that logo, SVG. There we go. So right off the bat we've got a few things here. Service worker, it's unnecessary for now. So we'll lose that. The logo is unnecessary. And there we go. Excellent. We get live updated errors indicating what we've done wrong. In this case, we've deleted something and left a reference. So we can start to remove that. Here, remove that. There. Just like in our hello world example, we'll get back to that state. We'll remove this test. Not best practice, but we're just trying to get something running with Redux as quickly as we can here. Alrighty. I'm a fan of 4 spaces, but 2 spaces is very common in the JavaScript world. Semicolons are unnecessary, but customary. React allows us to write these components in one of 2 ways. First, we have this traditional class ES6 way, where we can represent the component as being a series of hooks or lifecycle hooks, which allow us to render or receive the props, or on the component's creation do a certain thing, or on its unmounting do a certain thing. And simply by implementing the class procedures, like component will receive props, we'll be able to look and see something's changing with the component, and therefore we should take this or that action or do something in the future and then re-render by force. Alternatively, we can also declare an app simply as a function. We do something like this. We can just return JSX, so we'll say something like this. And that works just as well. Interestingly, with React, and particularly because we're using this build server, we are going to find that it is very easy to do something like create a style sheet and set a background color here, and we'll just invert the colors for now. And we will import that. And what's going to happen here is that it is going to, again, we'll look here, it's nothing going on. What's happened is, in the same way that we set up Babel loader in our Webpack example in the first video, Create React app has included a series of loaders for styles and CSS to allow those things to be imported into the bundle and then dynamically injected into the live application. And because the hot patching in the development server is particularly sensitive to context, it's able to note things like only the style has changed, and thus to hydrate those changes to the client, allow us to see something like the style change without actually having to refresh the page. Now if I go and, having brought that into the bundle, and say I make a change here, like we'll make this somewhat grayer, notice that there was no refresh at all. CSS just injected itself and was updated. Let's take a peek at the WebSocket and what's happening. Well, it looks like it's passed the error message in, but it's still done an update for us. Let's get Redux in and see what happens next. Redux is the core library that's going to allow us to do state management. And what I mean by that is, traditionally when we're building an application, we've got the view, the model, and the controller. And here with React, we've clearly got just not a complete picture. We've got only the view. So we're going to need to find a way to supplement React. Now, of course, we could take advantage of those lifecycle hooks or constructors in the class, and we could build ourselves something that has side effects and state inside of the component. And that is certainly the way to approach some limited problems where the scope of the state is not going to be much larger than maybe a variable or two, where you're going to be relying on some particular, maybe messy other piece of inline HTML or scriptlet that you've included. But in this case, what we're going to try and do is progressively build up on Redux as being a coherent and singular way to address both input-output effects that we want to do at kind of the app level, and also to make sure that when we make a state change, every single sub-module is going to be correctly updated, every single component is going to receive the correct bits of state, and only when those bits of state are updated. So we've got an efficient way to hydrate the state from server to client. So we are going to first build a simple example, and we're going to import create store from Redux, which is one of those functions that you can't get away from. Oops, we're not going to do it here in app, we're going to do it in the, we'll call it the entry point here again. We'll make a main function, and like our first example, we'll queue that on an event. So once everything's loaded, we get this main called, wherein we'll remove the event listener. And we'll move our render inside of here after everything else all set up. What we're going to do first is create a constant variable called store, which will be the result of our store. Create store takes as a argument a reducer function. A reducer function is a key concept in Redux. Redux being, again, the state management, state container library created by Dan Abramov. Excellent library. The documentation is thorough. He's created a series of videos on egghead.io that thoroughly document how to do exactly these things in much more detail, and he discusses from the ground up how to build your own take on the library. Once you've used Redux a few times, it's really natural to find yourself recreating those same patterns when you go and do something even kind of simple in JavaScript. And so there's been a bit of controversy on Hacker News and Echo.js and other sites that seems to knee-jerk in response to that, and you'll see kind of hit pieces that crap on Redux or say, you don't need to use this. Although there is some truth to the fact that it's being widely overused even for simple projects. That being said, when the project grows beyond a certain point, it's nice to have this common API and to think about actions in a way as simple as Redux does with its Flux standard actions. So let's again look at what a reducer is. It's a function that takes a state and an action and returns state. So what we've got here is, again, state, action, state. And the idea is that this state is going to initially be something, and it could be anything. The type is not forced on us. So if we say it's initially 0, then okay, maybe we're dealing with a counter component. So that's what we'll say for our first example with Redux is we're going to build a few action types here, and we'll look at that without getting into too much detail, as Redux provides a thorough API for dealing with actions, action creators, dispatching actions, dealing with stores, applying middleware to stores, middleware being functions which allow you to kind of intercept and chain functions and pre-create functions which exist as applied to the store in order to allow you to inject your own I/O boundary and create whatever extra functionality you need to add to the store. It's kind of like if you're ever adding new functionality, chances are you're creating a middleware. We will take as action types 2 possible strings, increment and decrement, which will respectively make changes on this count. So knowing that our state is initially 0, we're going to write our functions as such. And then, should any other action come through the stack, we want to be absolutely sure that either way, the fall-through case here is to return the state. But the notion is that we'll continue to write actions as our application grows in complexity and size. However, this reducer, even if it were to be moved into some sub-reducer later on in application development, we will find that it's still harmless. It's going to do its thing with state here and perform and respond to these actions, and only these actions. So now we've got the basis of a Redux application, but we're not connected to anything to do with React. So first, let's make sure that this is working. We'll dispatch a few actions to the store, and we can do that as simply as this. We'll say, this is not best practice with Redux, but we're going to dispatch a few increments. And you can also retrieve the store by using the function getState as such. Okay. Oops. Alright, so that looks correct. We have incremented 3 times, retrieved the state, and it is 3. So, how are we going to wire that data into React so that it is in some way subscribed to the React render function that when value changes or when our state changes, the app will be re-rendered? How do we cleanly do that as per convention? Well, react-redux, the other companion library to React and Redux that we installed, provides a higher order function called connect, which allows us to bind functions together and produce React-connected elements, Redux-connected React elements. And it also includes a provider element, which will receive as a parameter or a prop, like an attribute in HTML, a store from Redux. So now we've got this provider, and it's our actual parent because it's overseeing state. the authority on state in our application. Now, what we're going to be able to do then is that's what we're going to do here. We're going to the app, and we're going to import the connect function here, because in order to access this, we want to connect to Redux. Connect, we're going to map state to props is the function that we have to provide to connect in order to retrieve the current state and return it as a property to the component that we're rendering. So in this case, we're going to write a function called map state to props, and it receives an object that contains state. In this case, it will just be the state. And so we will say, we could just return the counter. We could just return state, and then the property will be represented as a number. But in this case, we're going to break it apart and assign in a key value pair value to state in this object. And now we're going to use a decorator and compose these functions together. Does it not want to use the connector? Okay. If you can't use the decorator syntax, which is experimental and subject to be removed anyway, then you can also do your composition like this. I wasn't aware that I couldn't do that with the create React app defaults. Okay, so now create React app, or sorry, connect is performing those. We're exporting a bound version of the app component, which should, due to our connect function and our mapping function, receive the state. And now here in the app, which receives an object, props, and as of ES 2015, one of the things that we can do is object destructuring. So instead of writing props here, where we would have to go, do something like, we could go, because of the object destructuring, or we could write it even shorter and go nice and clean. So now let's add our count here into the string, and we'll just say okay. So now we're displaying the value that's in the store. But how do we affect it? Clearly, we don't just want to be able to view things, we want to be able to change them and alter value and affect things to happen in state. Otherwise, this is just sort of a really complicated way to display variables. So, in order to do that, we're going to want to be able to emit these actions, same way I did here for our example. But we're going to want to be able to do that from within the React component that we've connected. So our default 0 now. Add a divider and a button. What we're going to do is connect can take a second argument where you define another function to map the dispatch to a series of props. And dispatch is a function which has been bound in the context of the store already by the provider. So when we write that mapper function, dispatch to props, we receive, again, the dispatch, and we return an object which is going to be the props that will be rolled into the app's props. So here we're going to say increment. We're going to define a function that, because dispatch is connected to the store and we've already written the reducer function and we know what the reducers, the action types are, we're going to write increment like that, and we're going to write decrement like that. And now, in the same way that we received in our properties those objects will have been folded together, and we'll be able to, in the same way, receive those from our object destructuring. And so we can assign those events by providing callbacks in the context of our HTML, which will work. It'll be wired up, and we're just going to not worry about that arg at all. It doesn't matter. We're going to simply dispatch those actions when we click the button. Well, let's make sure that works. Alright, so far that's the basics of React and Redux, and also using create React app to sidestep all the boilerplate setup.